In our last look at light, we established a clear divide. Rough surfaces scatter light in every direction, while smooth surfaces reflect it in uniform waves to create an image. A plane mirror is the purest example of this. It is a flat, straight piece of glass, silvered at the back surface to create a perfectly polished reflective boundary. But this raises a question of perception. How does a two-dimensional pane of silvered glass trick the human brain into seeing a deep, three-dimensional world existing behind a solid wall? In the modern world, our use of light has scaled into a global phenomenon. Here, artificial city lights compete with the natural glow of the moon, creating a haze known as light pollution. This excess light is more than a visual distraction. It disrupts the behaviors of nocturnal animals and birds and even interferes with human health by breaking our natural sleep patterns. Because light follows the same geometric rules, whether it's hitting a street lamp or a mirror, we have to understand the mechanics of how it travels to see how our artificial additions are impacting the planet. Start with point object O emitting rays OP and OQ. They bounce back as PR and QS, perfectly obeying the law of reflection. Our brain extends these rays backward to point I. Applied to every point on an object, this builds a complete virtual twin. This reveals the truth of the mirror. The world we see inside is a neurological projection, created by tracing reflected angles back to a point that doesn't physically exist. These projections share 4 specific traits. The image is always erect, is the exact same size, sits the same distance behind, and is laterally inverted, meaning left appears as right. Because the light rays don't actually pass through the mirror to meet at the image point, we call this a virtual image. It's an optical shortcut. You cannot capture it on a physical screen. This is different from a real image, like the one inside a pinhole camera. In that case, light rays physically converge at a point, allowing the image to be projected onto a surface. This table highlights the fundamental divide. Real images are inverted and form where rays actually meet in front of a mirror. Virtual images are erect and form where rays only appear to meet behind the glass. Distinguishing between physical ray intersection and optical illusion is the key to understanding how we manipulate light for our own uses. We use these flat reflections to make small shops feel larger, to see above water in periscopes, and to ensure high precision in measuring instruments by eliminating viewing errors. But the power of reflection can also be concentrated. 2,000 years ago, the Greek scientist Archimedes reportedly used mirrors as tactical weapons when the city of Syracuse was under attack. By aligning mirrors along the coast, he concentrated reflected sunlight onto the Roman ships. The thermal energy was so intense it ignited the wooden hulls. By mastering simple geometric reflection, we can scale light from a household convenience to a legendary source of power. This chart shows how light behaves in different environments. In the vacuum of space, it travels at a constant 300 million meters per second. But notice how it slows down as it enters denser materials, like water or glass. This change in speed is governed by the principle of least time. It states that out of all possible paths light could take between 2 points, it always takes the route requiring the least amount of time. When light bounces off a mirror from point A to point B, there are infinite potential routes. Since light speed is constant in air, the fastest route is the shortest distance. Geometrically, this occurs exactly when the angle of incidence equals the angle of reflection. This leads to a deeper mystery. If the law of reflection exists because light is choosing the quickest path through space, how does a single photon of light know exactly which route is the fastest before it even hits the mirror? The rigid rules of geometry we see in our mirrors are not just math. They are the universe enforcing a fundamental drive for cosmic efficiency.